The first method of sentiment analysis we will look at is called rule-based or lexicon-based sentiment analysis. This isn't a machine learning method. Instead, it uses a set of predefined rules that connect words to emotions or attitudes. For instance, the word great is linked to a positive feeling, while the word sad to a negative one. Each word is assigned a polarity score, a numerical value that shows whether the word is positive, negative, or neutral. The score usually ranges from -1 to 1, where any number above 0 indicates positive sentiment. For example, the positive word great can have a score of plus 0.8, while the negative one, sad, minus 0.7. These scores are then combined across the entire sentence or text to calculate an overall sentiment score. This approach is easy to use and simple to explain, which makes it a common starting point, but it has clear limitations. It can't handle more subtle expressions such as sarcasm or irony, where the literal meaning of the words doesn't reflect the true sentiment. In this lesson, we will compare two popular Python packages that follow the rule-based approach, TextBlob and Vader. Each package uses its own lexicon, a collection of words paired with their predefined sentiment scores. Because TextBlob and Vader rely on different lexicons and slightly different scoring rules, they may produce different results when analysing the same text. Let's try it out with these 4 sentences right there. First, we will use the TextBlob package. For each sentence, we will print out the sentence and then compute its sentiment score. Computing the sentiment score is straightforward. Use the TextBlob function and specify the text to analyse within the brackets. To see the polarity score, we use sentiment.polarity. Finally, we print the result to view the score. For example, the sentence, "I had a great time at the movie, it was really funny," receives a polarity score of 0.525, indicating a moderately positive sentiment. Sentence 2, "I had a great time at the movie, but the parking was terrible," receives a slightly negative score of -0.09. This score is close to neutral, reflecting the ambiguous nature of the text. Sentence 3 receives a positive score of 0.8, while sentence 4 comes with a polarity score of 0, indicating a truly neutral sentiment. This aligns with how most humans would interpret the sentence. Next, we will compare these results with the Vader package. To use it, we first import Sentiment Intensity Analyzer from Vader Sentiment module and then initialize it as Vader Sentiment. To compute a score, we call the function polarity scores and pass in the sentence as input. This function returns a dictionary with 4 values: negative, neutral, positive, and compound. The first 3 show the proportion of the text that falls into each category, while the compound score is the overall sentiment value, ranging from -1 to 1. You can see the output looks different from when we were using the TextBlob package. Here, we see the combination of different polarity values and the total compound score. The Vader package has given a higher positive score to sentence 1 compared to the TextBlob package. For sentence 2, Vader assigns an overall compound score of -0.4, which is more negative than TextBlob's score. Sentence 3 shows a significant difference. Vader assigns a negative compound score of -0.4, whereas TextBlob gave it the highest positive score of 0.8. This suggests that Vader may be more advanced at detecting nuance within the text. For sentence 4, both packages correctly identify the sentence as neutral. Neither package struggles with this neutral sentence. So, what's the key takeaway? When applying sentiment analysis, it's a good idea to test more than one package on a sample of your text. Different tools may interpret the same sentences in slightly different ways, and comparing their outputs helps you decide which one works best for your specific dataset and use case.